The following program is brought to you by Stetson University College of Law, the National Clearinghouse for Science, Technology, and the Law, the Law Enforcement Innovation Center at the University of Tennessee's Institute for Public Service, and was funded by the U.S. Department of Justice's Bureau of Justice Assistance's Capital Case Litigation Initiative.
Welcome to Crime Lab Essentials, the second in our series of webinars for the Bureau of Justice Assistance Capital Litigation Initiative, Crime Scene to Courtroom Forensic Training. I'm your host, Carol Henderson. I'm a professor of law at Stetson University College of Law and the director of the National Clearinghouse for Science, Technology, and the Law. This webinar is produced by the National Clearinghouse, the Office of Professional Education at Stetson, and the Law Enforcement Innovation Center at the University of Tennessee. Special thanks goes to the Metro Nashville Police Department for an inside look at their state-of-the-art laboratory facility. My two guests today bring you a wealth of experience in both forensic science as well as laboratory management. Ann Talbot, who is the director of the Metro Nashville Police Department, has been practicing in forensic science and administration for over 35 years. She has practiced in the fields of serology as a DNA analyst, trace analysis, blood alcohol toxicology, and controlled substance and crime scene investigation. In 1991, Ann became the crime laboratory director in Albuquerque, New Mexico. And she was also then selected as the system director for the New Mexico State Police Forensic Laboratories. During these tenures, Ann helped laboratories through the ASCLD Lab accreditation. She's been an active member of the American Academy of Forensic Sciences and has served as a board member for both ASCLD and ASCLD Lab. Ann was the founding co-chair of the International Association of Chiefs of Police Forensic Committee. Christine Funk started her career at the Minnesota Office of the Public Defender in 1994. In 1995, she was assigned her first forensic DNA case. Over the years, Christine gained expertise in forensic science, and her forensic caseload expanded to include many areas of forensic science, including drug chemistry and arson, as well as the study of false confessions and eyewitness identification in the context of complex litigation. In 2013, Christine moved to Washington, D.C., and she became the general counsel for the Department of Forensic Sciences. This provided additional insights into forensic science and also laboratory management. She serves on the Legal Resource Committee for the Organization of Scientific Area Committees, which is a joint program with NIST and the Department of Justice. She is also on the American Academy of Forensic Sciences Standards Board. Previously, she served on the board of the Minnesota Innocence Project and the Forensic Laboratory Advisory Board for the state of Minnesota. And last but not least, the White House Subcommittee on Forensic Science and Education, Ethics, and Terminology. Today, we are going inside Ann's lab and getting a view of 5 different disciplines: latent prints, toxicology, drug identification, firearms, and forensic biology, DNA. From intake to the report. This is a rare opportunity for attorneys to see the inner workings of a laboratory. However, I would also like to mention that Ann has given classes to attorneys at her laboratory, both defense and prosecution, in the Nashville area. In our first clip, Ann is going to introduce you to the hypothetical case, which will be examined by the various forensic disciplines in the lab. Then we will move to intake. If you want to ask questions during both the videos as well as our commentary, we will answer them throughout the webinar. Use the chat feature that you will find. If we are unable to answer a question during the broadcast, we will follow up with answers in a Q&A document. Let's begin our visit to a crime laboratory.
Hello, welcome to the Metro Nashville Police Department Crime Laboratory. My name is Ann Talbot, and I'm the director here at the Crime Laboratory. First of all, I'd like to just introduce you to a little about this particular laboratory. We moved in about 2 years ago, and we'd like to really thank our mayor and the city council and the police department chain of command for making this facility possible. It's beautiful. We received our accreditation about a year ago, and we are now a full working laboratory, accredited under our accrediting body is ASCLD Lab. Today we want to show something representative, Crime Lab Essentials. And this laboratory has 5 forensic disciplines. We consider that a full service laboratory. The only discipline we don't have is trace analysis, or sometimes called microanalysis. The forensic disciplines that we're going to show you today are latent fingerprints, toxicology, drug identification, forensic biology or DNA, firearms and tool marks. This is a local laboratory, or considered a local laboratory. When you're working with other crime laboratories, they might be part of a system or a private laboratory, but all of those laboratories, local, private, federal system, they can be accredited, and we'll give you the same type of service that we're going to demonstrate today. I'm hoping that the Essentials of the Crime Laboratory also unlocks the mystery of why it takes so long. Because as you watch today, you'll see that each forensic discipline has a lot of different aspects to it when it comes to the testing. We have not only security, we're talking about, each unit will talk a little bit about the chain of custody, the case documentation, the quality assurance that they go through, and then they'll describe a little bit about the report. The report is ultimately what ends up in the hands of our customers, and then we'll go into the courtroom from there. Each of the people that you'll see today also could testify in trial if they're called to testify. We hoped to make this a little bit more interesting by creating a mock crime scene or a scenario for a crime scene. And in this mock case that we made, everything that we've used today is also mock evidence, mock reports. So as you go through the crime laboratory, we're going to try to tie it back to the scenario we set up. It's one which would require requests for service from all of the disciplines in this crime laboratory, and that's why we've created it this way. So here's just a little bit of the description. A car is seen weaving on Interstate 65 in Nashville. Subject A is stopped for a DUI and fails his field sobriety test and is arrested and taken for testing. Subject A refuses the breath test, but he submits to a blood draw. The evidence that's submitted here is a blood alcohol kit. Meanwhile, the car was being prepared for towing when the officer saw some apparent blood smeared on the trunk. He calls for investigative backup. After a warrant's obtained, a full crime scene investigation is initiated. The crime scene investigators document the scene and locate, preserve, protect, and package the evidence. And here's the evidence they collected. Swabs from the apparent blood on the vehicle, large Ziploc bag of white powder and packaging material, patent prints from the trunk and on the white powder containers, and latent fingerprint lifts from the vehicle, a revolver and a semi-automatic gun, cups and bottles, and a bullet found lodged in the seat. The packaged evidence follows a chain of custody from the CSI investigator to the MNPD evidence storage section warehouse. So the detectives interview a subject A in our mock case here and learn of a second scene where subject B is found deceased. Crime scene investigators document scene number 2 and locate, preserve, protect, and package the evidence to include evidence from a search warrant, which is the clothing from subject A, the known standard from subject A, and then from the medical examiner they have evidence including clothing and standards collected for subject B. And then from the crime scene number 2, they've got bloody items from the scene, a spent cartridge case, and cups and bottles. So hopefully this will make it a little bit more interesting as you go through the laboratory. Although the examiners are not going to speak specifically to this evidence, this is the type of evidence that would be submitted in a case like this. And as you go through, there's a little bit of reference back to this particular scene. So the request for forensic service will come to the laboratory. Whoever's investigating it sends a form to us which initiates that the evidence is moved from our evidence storage section to our evidence receiving unit. And we'll demonstrate that the chain of custody from our ESS, or evidence receiving section, up to our ERU. From there, we'll demonstrate the evidence going to each of the forensic disciplines that are requested, and in this case, they've all been requested. And we'll show you how each unit goes through the testing.
Hi, my name is Billy Jackson, and I work here at our crime facility, crime lab here in the evidence receiving unit. Initially, officers will receive evidence or collect evidence from crime scenes, and what they will do is they will collect the evidence and they will take the evidence to our main storage facility. At that facility, officers will request that the information and those items be analyzed here at our crime lab. What will happen is the representative from that unit will bring the items here. What I will do is I would take the chain of custody from them, and then I'll log it into our system here, and then we store it in our storage facility. And then what they would do is the other units would check the items out from us for further analysis. Good morning, sir.
Hey, Bill.
Got a regular load today?
Yep.
All right, let me make sure we got everything together here. You doing all right today?
Good.
All right. Have a busy day today?
Not too bad.
All right. Hoping the same for myself. All right. And then we'll put this in. All right, sir. Go ahead if you would. Okay. All right.
Yeah.
All right. Appreciate
Thanks,
you.
Bill.
Thank you,
See
sir.
you next
You
time.
have a good one, okay? All right.
Well, we're back after our evidence intake, and I have a couple of questions, one for Ann. Are there set protocols for evidence storage? Like, what goes on behind the desk there?
Well, once the evidence is received and it's checked into our LIMS system in the laboratory, then we have vaults in our
What's a
evidence.
LIMS system?
Our laboratory information management system.
Okay.
That is what we use to keep the chain of custody of our items of evidence. And also we do our reporting and our technical notes are all in the LIMS system. So eventually we end up with a report that's printed out of our LIMS. But it starts with the chain of custody. They're in our evidence receiving unit. And they will choose a location in one of the vaults that's in that unit. So all of the narcotics evidence goes into a narcotics vault. All of the firearms and ammunition go into a separate area in the vault. Anything that needs refrigeration goes into a vault that has refrigerators. And the rest of the evidence is in our general vault.
Okay.
Until the examiners come and check it out.
All right. And also, is there any like accrediting body for evidence storage that would have how it should be done?
There is an accredited body for evidence storage. It's IA, International Association of Property and Evidence, IAPE. And they do have accreditation standards. I think they are also used as a resource by CALEA if a police department is an accredited police department.
And what's CALEA too?
Oh boy.
It's an accrediting body
For police departments,
Right,
yes.
okay.
I can't remember what the acronym stands for.
Okay. And is it required to have ASCLD accreditation? Do you also have to have an accredited intake division or evidence storage?
Well, as an ASCLD lab accredited laboratory, that's the accrediting body. There are a lot of standards and criteria that you must meet as a laboratory, and those include chain of custody and the way that you handle evidence so that it's protected against cross-contamination or deleterious change, or protected against being lost.
Okay. And Christine, you were a general counsel in a laboratory. Did you ever have any cold cases that people had to come and retrieve evidence or anything like that? Or what would you do in those kinds of, or as a lawyer with a cold case?
So we did have a case actually at the laboratory that was a cold case, and the laboratory in DC where I worked was a new laboratory. So when the case was requested for testing, it had to be retrieved from a storage facility that was maintained by a local law enforcement agency. And then it was brought into the laboratory and it was checked in just like you saw. It was a very old case, and it had something that we documented when it came in, which was that the seal you saw, the seals on the packaging, on the pieces of evidence in the video clip, the box that came in the seal was not properly maintained. And so as is common procedure in labs when something happens like that, it was packaged then properly, and it was documented how the packaging was originally, who repackaged it, what steps did they take to ensure the integrity of the evidence.
Did they take a photo? How did they document it? Like take a photo of that package that had not been, or when it was open or something, that, or at least documented in writing?
You know, my recollection is that it was both.
Okay. All right. So that's one of the things that we have to think about, is whether there's an accreditation of actually the evidence storage. Is the evidence stored at the facility? Is it then sent someplace else? Like, how long do you keep a piece of evidence in your facility?
Well, first I'll answer, is there an accreditation of the evidence? In a crime laboratory, the laboratory accreditation is what oversees or what guides these evidence in the lab. And our laboratory, and I think a lot of other crime laboratories, only have the evidence there while they're testing. So it may come to the laboratory, it'll wait in a evidence receiving unit until the scientists pick it up, test it, return it, and then it'll go back to the submitting agency.
Okay.
In our case, we're the only agency that's using the crime laboratory, but in other labs, it'll go back to whichever agency submitted it.
Okay. All right. Well, let's
Can I
move
add
on.
something?
Yes, go ahead.
Just as another practice tip, whether you're a prosecutor or a defense attorney, now this is going to depend a little bit on the culture in your laboratory and also the rules of discovery in your jurisdiction. But getting that chain of custody is one of the most critical, and I might add as a lawyer, one of the easiest things you can do in evaluating what a crime lab has done and whether or not they've done it properly. What you should expect to see in that limb system for where we are right now is officer whomever brought it to the crime lab on such and such a date at such and such a time. It was received by officer or special agent or crime scene specialist or whatever the title is, whoever with their full name, date, and then it should say where in the crime lab did it go. And it doesn't just say refrigerator or vault, it should say, vault A, shelf 6. And the next thing you should see is that it came off of shelf 6 in vault A and was turned over to, for example, the latent print department. If you see that it came off of vault 4, shelf 3, there's a problem there. It's been moved somehow, and that move hasn't been documented, and that's a really good clue that there's a problem with the chain of custody.
Well, speaking of latent prints, that's where we're going to go next. So if we could see the clip on latent prints.
Good morning, John.
Good morning, how are you?
Good. I'm here to pick up the items of evidence for latent prints.
All right. There you go.
Thank you so much.
Yes, ma'am. Have a good day.
You too. Hi, my name is Monica Kent, and I'm a latent print examiner in the latent unit. We just picked up our evidence at the evidence receiving unit, and we have brought it back to the latent print unit for testing. Upon receiving this evidence, we inspect the integrity of it by checking the item packaging and seal. Once we have opened the item of evidence, we begin our case documentation to describe it, how many items are present, the type of items present, such as where the lift was located from. And once these initial notes are collected, we begin our testing process. The first step in our testing process is latent print analysis. During analysis, we examine the latent prints for clarity, which can be affected by several factors. These include the surface the print was deposited on, the substance deposited by the friction ridges, such as sweat and oils, paint, dust, or blood, the method used for development, and any type of pressure or movement at the time of deposition. In analysis, we are ultimately determining if sufficient and reliable information is present in the print in question. We have digital image software available to aid us in our testing and documentation process. We may use this to improve the clarity of the print using a variety of processing tools. If the print has sufficient and reliable detail, we begin our next phase of testing. This is the comparison phase, where we take our latent print, the unknown, and a known print standard side by side as we examine to see if the same characteristics are present if they are in the same sequence and spatial arrangement in both the latent and the known standard. In reviewing the request for examination, the standards that are used for comparison may include a listed suspect, victim, or elimination print submitted. If the examiner determines there is sufficient agreement observed in the compared characteristics, then the resulting conclusion is an identification. In cases where we do not have a listed suspect or victim available for comparison, we do have the ability to use a database search tool in the form of an automated fingerprint identification system to search those remaining unidentified prints in our case. Amber is going to demonstrate the APHIS testing process. APHIS testing begins by digitally capturing or uploading the latent and marking searchable characteristics. The examiner inputs this information along with the orientation and location, such as finger or palm, pattern types if applicable, and then launches the search. The APHIS software searches our database using the input from the examiner, resulting in a candidate list. Known prints with ridge arrangements most like that in the latent will be ranked in order of possible matches. The examiner must ultimately make the determination if there is a true match present in the list by reviewing each matching candidate provided. Jackie is demonstrating a final stage in our testing process. As a quality assurance measure, before a conclusion is reported, the prints go through a verification process where another qualified examiner independently conducts their own analysis and comparison to evaluate the accuracy of the original examiner's findings. Technical and administrative reviews are conducted on the casework of the unit before reporting. We prepare reports from our analytical notes for the customer based on the results of our examinations. The report lists the items tested and resulting conclusions. The original examiner will sign their report.
Now we'd like to talk a little more about latent prints, and especially about report writing. So Anne, could you talk a little bit about report writing?
Yes, I'll give this introduction about report writing in general, because eventually that's what our customer, the criminal justice system, gets. As an accredited laboratory under ISO 17025, which is the accreditation international standard that's used for testing laboratories, we've got a lot of standards and criteria that laboratories meet. In addition, there are supplemental requirements from the accrediting body. So in ISO 1705 section 510 are the instructions for reports. So this is going to be consistent from accredited lab to accredited lab for general things. Now the verbiage and the way that a lab reports, as long as they're meeting their ISO standards, may be different. So in general, the results of a test or examination carried out by a laboratory should be reported accurately, clearly, unambiguously, and objectively. Data from the analytical testing must meet the standards, the technical procedures of the laboratory, so that when you get a report, you should know that the laboratory is following their technical procedures and they've got all the essential things that ISO requires. Now, unambiguously is sometimes a difficult word, and so laboratories are really trying to make that unambiguously. And I will give an example of a report for latent prints. And as we go through each discipline, I'm going to read the example of how the verbiage that our laboratory uses. In the example we gave, we had subject A and subject B and latent prints from two different crime scenes. So the verbiage that our laboratory uses, first of all, we describe the evidence. We give a number to each latent lift card and each print that we're examining, and then we write results and conclusions. And so in this example, we've got a photograph of the patent print. We have a lift card from a Diet Coke can, a Diet Sprite can, a Red Bull can, and some white, and the white powder packaging. So, and then we go back through with our conclusions. No impressions on this item identified to the subject, subject A. Impressions on item 2 identified to this subject, subject A. No impressions on item 3 were identified to the subject. So that's how we will go through with each item. And then if it's an inconclusive, we will say inconclusive for this item, it needs major case prints from the subject. On item 5 in this case, no impressions on this item were identified to the subject. So then there's some supplemental that'll say APHIS quality impressions have been searched and registered in the MNPD APHIS system. Additional searches will be conducted as new known impressions are entered into the database. So these are all requirements that we need to say. We need to say if we have an inconclusive, why, and in this case we said the reason why is we need major case prints. So there will also be a disposition of the evidence on each of these reports. It's another requirement. And in this case, we said that our evidence was returned to the latent print vault. And that's the only evidence that we keep in the laboratory because it can be searched over and over again.
Okay. I have a question. How do lawyers get copy of these ISO guidelines or standards? Because again, we'd have to know, well, what do they say? And then how can we show it has been done or hasn't been done?
Well, ISO 17025, as with any all of the international standards, as far as I know, it need to be purchased from the International Standards Organization.
And we did have a discussion about this
Yes.
earlier. So Christine, why don't you say what we found out, at least what's going on with NIST, I think, with the ISO guidelines.
Okay, so NIST, which is the National Institute of Standards and Technology, it's a government organization, has worked out an arrangement with, maybe Ann, you can help me out here, I don't know who's in charge of ISO 17025 or ISO, has worked out an arrangement with somebody so that defense attorneys and I believe also prosecutors in the criminal justice system can have access to these standards at no cost. Mm-hmm. And I do not have a website to provide you with right now, but I'm certain we can get that
We will post
for
that,
the participants and post that.
Right. And then how about with the APHIS equipment and things like that? I know a lot of people say, well, how many hits do we need? Or does your lab have a certain set number, like that would be 10 or 20, or it depends?
I'm not certain exactly of your question, but what we do is when we enter an unknown latent print to become to the APHIS database, it will give us a large list. There's of prints that are similar. And then an examiner will go back through and they will look at the latent print compared to the list that the automated fingerprint identification system gives them. We routinely look at between 30 and 40 from that algorithm, and then to see if we get a match. If we do get a match, then a forensic scientist looks at the match to verify it.
Okay. Now, as a lawyer, what kind of discovery would you want when it came to, say, latent prints in this particular case?
So this is another thing which I think for both prosecution and defense, this is very helpful. You'll get a final report, usually that's the first thing, and then you have to ask for the rest of the file. One of the things the latent print examiner stated in the very beginning, which is true for all of the forensic disciplines, is there's an inspection of the integrity of the packaging. And you're looking at that really for a couple of different reasons. So first you want to look at it, and I've certainly had a fairly spectacular example of this where the packaging had reddish brown stains on the outside of the envelopes. And some of these envelopes did not contain things that had blood on them on the inside. So that's an indication that there was some sort of contamination event perhaps that occurred when the evidence was being collected. You may not find that in the body of the scientific report, but you'll find it when the analyst makes their notes, like she talked about in the video, where she's talking about, she looks at the integrity of the evidence. You also want to look and see if the packaging has been opened or if the seal's been compromised. That can also be information that can be of help to you when you're analyzing maybe the value of what's inside the envelope. And the other thing that the analyst sort of referred to, and we'll hear other analysts talking about this throughout our time this afternoon, sometimes what's written on the outside of the envelope and what's actually within the contents of the envelope are not the same thing. And that's not a reflection on the lab or the analyst that it came in that way, but the analyst will document both what it said on the outside, this is a pop can, and then what was on the inside. And if it's 3 tuna cans, she's going to write that down. So that's information, whether you're the prosecution or the defense, that you're probably going to want to know before trial. So that's the easy first one, is those notes. The other thing, the other pieces that I might ask for, particularly if I'm going to hire an expert of my own, well, first of all, if you're going to hire your own expert, they can frequently provide you with a list.
Right.
But you saw on the video where the fingerprints, you saw the little green dots on the print. She's marking areas that she finds to be of interest or of some value. Not every laboratory preserves that. Some laboratories do. Some laboratories are starting to. I think it's a valid question to ask. The other thing I would ask for, and again, not every laboratory preserves this, but that list of the 30 to 40 candidates, or maybe some labs do 10 or 20 candidates, I would like to look at those perhaps as well, particularly if I'm going to be hiring an expert.
Right. Correct. Well, we're getting quite a few questions here from our audience. The first question here is there a national standard? Now, I think, do you mean, the previous question, though, is are there a set number of points that the lab has to match in a print before calling it a positive identification? Anybody want to take this? Because I know before people would say, oh, it has to be 12 or 16, and that was in,
And then 8
and then
for a while,
8 for a
yeah.
while. Yeah, so it would go back and forth. But I don't know if you want to weigh in on this, Anne.
I can weigh in a little bit. I'm not a latent print examiner. I don't have that in my past history. But this I do know, that there has been in the past talk of a set number. And I think that idea is kind of faded because there are a number of things. It's not just points. There are other things that can make you feel certain that it's an idea.
Like ridge characteristics.
Ridge characteristics, bifurcation. Well, those are all little points they mark. But through the process, I mean, sometimes there's 8, sometimes there's 15, but there might be 7, but you're absolutely sure for some other reason.
And a lot of this comes down to the integrity of the examiner, of course, experience of the examiner. But I know that there's been a lot of questions about latent print identification, and there's been a lot of research. And right now, NIST, that is one of the subcommittees that they're working on with the Organization of Scientific Area Committees. They're looking to see, can we set standards? Should we set standards? So I think for our prosecutor who asked us, is there a national standard, we might have to say, No, not yet, I think, until we
Right.
see what
I agree.
standards are going to be generated from the OSACs with NIST. Now, we have another question from Philadelphia. It says, it seems the determination is vague and conclusory. There's nothing in the reports that I've seen that describe exactly how the latents and knowns match. When another person from the same lab confirms the results, they're agreeing with the conclusion, but not the exact method. So maybe you can talk about
Well,
confirming.
I would say when technical review happens or verification, they redo it so that the first examiner has come to a conclusion, perhaps an ident, and the second examiner is going to look at it and verify that. The methodology is the same. In our laboratory, we use ACE-V, and I think that's very common with laboratories, but in latent prints. The second examiner is going to do a full technical review and verify that that is an ident. So it's kind of done twice in the laboratory, and it is not uncommon for there to be discussion between two examiners about this point or that point, in which case we have a third person come
And also look at it
And
from your
also look-
lab or from outside your laboratory.
in our laboratory, unless it comes to the point where a decision can't be made, then usually a unit supervisor or perhaps someone from outside could come and look.
Right. And I think we still have to be, aware of when we had some confirmation bias, which occurred
Right.
with the FBI, and I hope all of the lawyers, whether you're a prosecutor or defense lawyer, are going to read the results of the report that when they went and re-examined. This was when Brandon Mayfield was wrongly accused of being the person who actually was involved in the bombing in Madrid of the train. So I think whether you're prosecutor or defense, you should be very aware of that, what was done, how things have been corrected, and we will talk more about errors and correction. Humans are involved, so errors do occur. But we have to look at them and see how do we make sure we have less errors, and also how do we resolve error situations. So, go ahead,
I want to
proceed.
add just a little bit more on the commenter who says there's nothing that describes exactly how, you're right, in the report, there's absolutely nothing that tells you how it is that the analysts came to the conclusions that they did. And this is why in discovery, you're going to want to ask for them to print off for you that computer screen where they've got the green dots highlighted, whether it's at, an arch or a loop or a dot or an endpoint or a bifurcation, whatever it is. And you're also right that it is entirely possible that the second reader, in doing an independent evaluation, of course, that means they don't get to know what the first analyst thought was significant. So they may find different points that they think are significant, and that will be a separate, hopefully documented, portion of the file, so you can find out what was the second examiner thinking that was relevant when they came to the conclusion that it was in fact a match.
Right. Now, here's another interesting question. Actually, when we were having dinner last night, we had some discussion about this too. First, can prints be lifted from paper? Anne?
Prints aren't necessarily lifted from paper. They are visualized using a chemical called ninhydrin. So the oils in the water from a print on paper, they'll be processed using ninhydrin, and then a photograph that'll be taken, that will be what goes for comparison in the laboratory.
Right. But the second part of this is, can prints be lifted from a bullet? And we did have this discussion last night, so let's talk about that.
Well, if you consider a cartridge casing with a bullet in it, the projectile, so I don't know whether you're talking about a bullet that's, we had a request for service for print lifted from a bullet that was in a body. So no print from that bullet. But potentially from a cartridge casing, but a fired cartridge casing is going to get hot. So when you're talking about if it's a not spent cartridge casing, I think there's a possibility, but a fired cartridge casing is going to be even more difficult. A bullet or projectile that's traveled, no.
Any comment? I know we were all talking about this last night.
We were all, and this is one of those things about forensic science that I think lawyers find frustrating because it's just so beautiful and clear on television. There's a right answer. And very frequently in forensic science, the answer is it depends, right? Can you get a fingerprint from a bullet? Sure, if I take it out of the box and I've been sweating and I very carefully wrap my finger around and you use the proper collection techniques, if my hands are bloody, you probably won't get the definition you need to get a usable print. Again, if it's fired. So there's always sort of a yes but or no except when that you'll find in forensic
And
science.
context, I mean, we have to see what the circumstances were. Here we have another question. Oh, did you have something, Ann?
I was just going to say, yes, when I said bullet, no, I meant a fired bullet. It's a projectile. But yes, I agree with Christine. If you're really careful, you could get a print on it.
Now here we have, why would evidence of contamination only be in the notes and not in the report itself?
Evidence, well, I think Christine was referring to the packaging. So since like a latent print examiner is looking at the evidence within the packaging, the latent prints themselves, that's going to be what's on the report. And so if the red brown stain on the outside of the packaging is there, they're going to document that, but that's not really what they're looking at. They care about what evidence is inside.
That's why discovery is so important
That's
and
right,
asking
yes.
beyond
Yes.
what's in the report.
Right,
I
is
mean,
looking at all of the files. There may have been a contamination event, and they decided to, particularly in forensic biology or DNA evidence, they're not going to use that one. So when they write their report, perhaps, depending on the lab's protocols, they're not going to mention that one because they're not using it, they're not relying on it. As an attorney, you may want to know about that event, even though that evidence isn't coming into court.
Right. We had one question here with confirmation bias. What is confirmation bias?
Whew. Well, that's a 2-hour seminar.
I know. Well, we could also, actually, you should look up, actually, the person who's written a lot in this area is Itiel Dror.
Yes.
D-R-O-R. He's from London. I think it's the University of London, the College of the University of London. I have looked
ETL
at,
is
but yes.
I-T-I-E-L.
Right, D-R-O-R. But he has written extensively in this area. But I don't know if you want to just give a brief, because I know we have to move on to some of our other
sure.
topics. But
So here's the easy one, okay? And as I progressed as a defense attorney, I saw this less and less, but it's going to depend on your jurisdiction, and it's going to depend, quite frankly, on your submitter. So if you get a submission that says, please find the defendant's DNA on the gun, right? Rather than, please test the gun to see if there's a DNA profile on it, and then compare it to the defendant's DNA profile to see if it's a match. The words matter. If you say to an analyst, listen, this is a really bad guy. He's raped 3 other women. We can't prosecute one of them because she's disappeared and one is here illegally. We really need to get him off the streets. You've got to find a DNA profile. DNA profiles these days, which we're going to touch on later, get messy, right? And in many forms of forensic science, there can be sort of a tipping point of, well, I'm not sure. When you have confirmation bias, what you're seeing is somebody who is oh, I've already decided this person is guilty, or that this person left the DNA on the gun, wrote the check, robbed the store, left the print. In a close case, and there have been studies that have confirmed this, and particularly in fingerprints, when your coworker has just said, this is a match, I just need you to confirm that, there is a tendency sometimes to give more credence to that information than the actual point-to-point comparison of the latent print, which is why the FBI took the lead in changing their policy. So originally they just did confirmations when the prints matched, and after Mayfield, they changed their policy so that there's a certain percentage of the time, even if the prints don't match, you give it to a second examiner. You don't say, hey, this one's not a match. You just say, tell me what you think, to see whether or not, to sort of reduce, although not eliminate entirely, that confirmation bias.
Right, and there have been a lot of studies in confirmation bias, and in fact, we're going to do one of our webinars on confirmation bias. We also had a panel at the American Academy of Forensic Sciences and a plenary session that also talked about confirmation bias, and again, you can get that material on the ncstl.org website. Okay, we have, again, we will be putting some of this information out. Please look at the bibliography of information that we have posted, which has a lot of this, and if you have any requests, you can request this information and look through our database, which is very easy to search. Okay, well, I think then maybe we should move on now, I think, to our next one, which will be toxicology. So let's move to the toxicology laboratory.
Hi, my name is Jessica, and I am the forensic technician for the toxicology unit. I usually take our cases, open them, accession them, and hand them off to our scientists. So first I'm going to scan in the kit. And I'm going to take pictures or scan in a picture of the front and back of the box. And we have our submission form and our blood tubes. Next, I fill out the laboratory use form. And I image the tubes the way they came in and our submission form. So then I go and itemize our kit, so to actually take the tubes out of the kit via the computer. Now it's ready to be handed off to the scientist.
My name is Heather Singletary. I'm a forensic scientist in the toxicology unit, and I'm here to show you kind of what we do on a daily basis. So we test for blood alcohol and drugs in blood in DUI cases. And before analysis begins, our technician who logs in our cases will physically bring them to us. We will then log them into our own personal toxicology vaults. And so when analysis is ready to be performed, we will pull them out of our fridges or our vaults and bring them out for analysis. And so what I'm about to show you is our prep for alcohol content in blood. So now I'll show you an example of pipetting and preparing for our blood alcohol that we will run on a GC FID mass spec. So our first thing that we pipette is a known internal standard that we base our calculation off of. And then we take our sample and pipette the contents into that known internal standard. Make sure there's a good seal, and then that is ready to be put on the instrumentation. So now that that sample has been pipetted for alcohol analysis, we will now load it on our instrument that measures the amount of blood alcohol. And so with every batch of data or batch of analysis that we run, we do a full calibration and quality control. So it's a daily check to make sure our instrument is performing correctly and that all of our standards are measuring to the amount that we say they are. So we make a sequence list that correspond with vial numbers on the actual instrumentation. So I will load them according to the vial number, and another analyst will actually recheck the sequence after it has ran. So now that our sequence has finished running, we can now look at the data. So we're looking at the data to make sure all of our known calibrators and quality control has passed, and that way that we know our unknown blood samples are quantitating correctly. So what we're looking for is our actual known, so we have peaks for our ethanol and then peaks for our known internal standard. So we're making sure all this passes and we get a nice linear curve, and in between these curve points is the samples that we're looking for on a scale of 0.01 gram percent to 0.4 gram percent. So now, once this is passed and we have all of our data collected, we are going to go look at a marijuana screen test. So now what I'm going to demonstrate is how we screen for marijuana components. So it's not just straight marijuana, there's actually some metabolites that it'll break down into. So we're actually looking for those as well. So here is an example of this test that we run. So it has a coating on it that it's going to show up kind of a different color. It kind of turns clear if there's marijuana or its known metabolites present, and if it's negative, you'll get a nice blue color. So it's kind of a nice, almost visual test, but it's coated with specific antibodies that's going to fight to attach to those marijuana components and give us an absorbance reading. It's not a quantitative analysis, it's more qualitative. So we're going to walk over to our screen and our reader and show some data. Once it is finished and we're ready to analyze, it's going to measure the absorbance. So with this test, with it being qualitative, our QC is actually wanting to make sure our negative is actually negative, and then we run a known cutoff and a known control. So that's kind of where our basis of a positive or a negative will fall into place. So now we just performed a marijuana test. We actually need to do a full drug screen for a more qualitative assay to see what kind of drugs we need to move on for further analysis to get a quantitation for. So you saw before with the blood tube, we can't necessarily put that blood onto an instrument like this. We do need to clean it up a little bit. So after prepping for a drug screen, you'll get something like this. It's clear, but it actually contains the drugs that we are looking for, but in a more cleaner way to put on the instrumentation for analysis. So what this is an LC-MS-MS, and we are looking for about 100 known different drugs, ranging from drugs of abuse to antidepressants, and even over-the-counters. So now that we've looked at our drug screen and can determine what drugs are present in those blood samples that we're looking at, we performed another extraction for our quantitation. It's a little bit different than our screen, but it cleans it up to get where we're not putting actual blood on the instrumentation. And we do run calibrators and known quality control with this extraction as well. And that calibrator helps us determine, or helps give us an actual quantitative value for those drugs that we find present. Okay, so once every part of the data and all drugs and alcohol that we found is inputted, I will then pass off this case to an independent analyst to do a tech and admin review. Hey, Emily, do you mind reviewing my case for me?
Yes, I can.
Thank you.
Mm-hmm. Hi, my name is Emily Back, and I am an analyst here in the toxicology unit. I just received an analyst case file, so now I'm going to do technical and administrative review on that case. We go into the case here, and we pull up the final report, and this is what it's supposed to look like, and it's got all of her results here. The measurement of uncertainty should be in here as well as all the subject information, the officer who submitted the case, as well as what time it was submitted and the time that the blood was collected. So that's all part of the administrative review as well.
Before we talk some more about toxicology, I'd like to mention two things. One is CALEA stands for the Commission on Accreditation for Law Enforcement Agencies. And the other is that I would like to ask Anonymous 78801, could you please write a more specific question? You asked, does the NAS report change anything? If you could tell us a little more what you really want to know about change in a particular area or in general about forensic science. One of the questions we received during the video was, what does the Tox Vault look like?
Well, in our laboratory, each unit, each forensic discipline has a vault within the laboratory itself. The Tox Vault is a vault with an extra tier of security on it. In it, it has 4 refrigerators. Those refrigerators, each refrigerator is assigned to a scientist. So when the scientist checks out a toxicology case, and if they can't work on it right away, they'll go into the vault, they'll put it in their location within that vault. So it's actually a refrigerator within a vault.
Okay. You want to talk about the lab report? I think that would be our next thing
Sure.
that we
I
want
want
to
to do
see.
something about the vault.
Oh, yes, if
just
you want
real
to talk
briefly.
about, yes, go ahead.
So when you're looking at your individual lab, understand that not every lab was built at the same time by the same people with the same amount of funding. And so it is imperative that lawyers call up the scientists and say, I would like to come down and meet you. You're not going to get a tour of the DNA workspace without giving up your DNA, and maybe not even then, depending on the lab's policies. But understand the tox people are not working next to the DNA people. The latent print lab is not within the same typically area, right? Everything is separated. And even if the tox people have their own vaults, that doesn't mean that the DNA people have their own vaults. And so for every single crime lab, as a lawyer, you need to do an analysis of, it's a really good question, right? When you're looking at your chain of custody and you see it came into the lab and it was on this shelf, came off that same shelf and went to a latent print examiner, what did she do with it? Where was it stored? How was it stored during the time that it was in her possession? It might be several weeks or even several months. And so it's critical to find out for each individual laboratory and for each individual section what's going on with that evidence while it is not in the evidence storage vault.
And then, Anne, you wanted to talk about the language of a report for
Yeah.
toxicology.
Yeah, the language of a report for toxicology would also describe the evidence. In this case, it's blood tube. And in the mock scene we had, the subject A was taken for a blood alcohol test. And in our laboratory, we do both blood and drugs in blood, both alcohol and drugs in blood. So our report would have the blood as the evidence, and the results would be item 1, ethanol was found at a concentration of 0.112 gram percent. And you also, on a tox report, would have to see the method that was used. So that should be on a tox report too. In our case, it's an HSGC-FID-MS. So the other thing that was found in this particular case was marijuana, but on a report it reads 11-nor-9-carboxy-delta-9 THC, 7.4 nanograms per milliliter, and that was done on an LC-MS. So you should look for the concentration and the method. When Heather was discussing this during the video clip we just saw, she talked about a quant and a qual. So a qualitative analysis is going to tell you what it is, and a quantitative is going to tell you how much. So when we get to the measurement of how much is there, that's where measurement uncertainty comes in, and your report should have a measurement uncertainty for everything that's reported for concentration. So that's your quantitative amount. In our case, in our laboratory, we have specific measurement uncertainty for ethanol results. It is the average of 2 tests. We run everything in duplicate. It is plus or minus 0.008 gram percent at a minimum of 99.73% confidence level. When it comes to drugs in blood, we look at about 100 different drugs when we run a screen. So there are the measurement uncertainty for all of those, it would be huge on a report. It would make the report unreadable. And so when you find, so our report says drug uncertainty of measurement is available on request. We do get a lot of requests for those. So if we're reporting the THC, cocaine, benzoylecgonine, whatever it is, on request, we'll also send you the whoever requests the measurement of uncertainty.
And maybe we should talk, I'm sure most lawyers think, if I hear uncertainty, I don't like the sound of that. So that's the one thing.
Welcome
Maybe
to science.
Welcome to science. Yes, maybe that's one thing that
Welcome
should be
to science.
clear. If you just say, oh, it says that there's uncertainty, oh my gosh, you know. What maybe, I don't know, Anne, if you can say a little more about the
Yeah, I was going to talk a
uncertainty
little
is-
bit more about that when we got to the drug ID.
Okay, let's wait for that
so
then. I think that's a good idea.
I think we can describe it a little better with the drug ID.
Okay, that's fine. One of the questions from our online audience is, do you perform double-blind proficiency testing?
In our laboratory, we do not. We are proficiency tested, a lot of proficiency tests, but we don't do a double blind proficiency test.
Okay, is there a reason for that? Perhaps we could explore that a little more.
Perhaps it's a practical reason. It's very difficult to do a double blind, to get it to go through the system so someone has no idea that it's a blind proficiency test. So we'd have to get someone to actually perhaps ingest alcohol, get it drawn by a nurse, put it in a kit, get it submitted by an officer. It would have an incident number on it so that there was no way to tell. And that's a lot of things to go through to kind of make sure that the examiner doesn't know it's blind. It can be done, it's not easy.
Okay. Would you want to weigh in on double-blind testing at all?
You know, I'm a fan of double-blind testing, but nobody does it as far as I know in the United States when it comes to crime laboratories for the exact reasons stated. I think that lawyers would really be surprised at how much contact analysts and labs have with law enforcement officials that are submitting test results, for good or for ill. That's another thing you should ask for in discovery is any communications between law enforcement and the lab, which should be documented. I think pretty much ISO would require that those be documented.
Yeah.
Whether or not you can get them, again, goes through your discovery rules in your state,
jurisdiction.
that sort of thing. But certainly, also in discovery, you can ask for the proficiency test results for the analysts that are involved in your case. I think that's a legitimate request. I don't know. I'm not necessarily certain how significant it is because the questioner makes a really important point, which is you know when you're being proficiency tested. You typically have as much time as you want to take on it. You know this is a test. You know if you fail it somewhere, sometime, some defense attorney is going to ask for it, and you're going to be on the stand and you're going to have to explain it. So do they use more caution in proficiency tests than in regular testing? Well, what we know about things like, you know, cognitive bias is that probably. I just wanted to mention, if I could, some other pieces of discovery that I saw, particularly in this Tox case, that I thought were really important. So the first thing is the submission form. I don't know what's on the submission form in the city of Nashville. I have seen submission forms from law enforcement in other parts of the country. Some of them are very straightforward. Here's the case number, here's the date, here's the defendant. Some of them include information like he was falling down drunk, he passed out in the back of the squad car, he took his clothes off in the jail cell. None of that has any impact on a scientist's analysis of whether or not there are drugs or alcohol present in a blood sample, and that would be something that could easily be categorized as biasing information. So if, for example, you're a prosecutor working for, and you have a lab that reports to you or your office, it might behoove you to start having conversations about, do we really need this information? Cognitive bias is becoming more and more something that I think people are becoming aware of, and it's not necessarily necessary. That was my first thing. The second thing I saw in the Tox example was, for the first time, we saw one analyst who essentially cleaned up the sample, and then she handed off the prep work to another analyst. When you get your report, it's signed by the analyst who did the analysis, right? This is another reason why you want to get the entire file, because in the entire file, there will be clear documentation of who got the evidence out of the evidence locker, who prepped the samples, what type of prep did they do, and when did they hand it off to the next person. And then it's up to you and your jurisdiction, and maybe a conversation between the prosecution and the defense about whether or not anyone cares. If you want a complete chain, you're going to need everybody that's in that chain.
That's right. Now, we have some other questions coming in here. One question here is regarding known metabolites of marijuana, and it said, and this really applies to any time you are looking at metabolites. How do you confirm these metabolites did not come from something else? Like this is the eating poppy seed bagels and testing positive for opiates, which has come up.
Well,
I thought you have to have aspirin too. Wasn't there something else that was involved there?
I will say, first of all, that I'm not a toxicologist either. I've been pushing paper for a long time. But I can say that we look at the metabolites of marijuana. 9-carboxy-delta-9 THC is one of those, and I am looking here on this list. I don't see any others. But for poppy seeds, for example, I think that's going to look a little bit different. This is so specific. I really don't know more to answer, except that I know that the technology we're using is very specific, and we are looking at metabolites. We're looking at 100 drugs and their metabolites. So I can't answer any more than the specificity of the test.
Right, and I recall a lot of that stuff about the poppy seed bagels, that came up at a time when we did not have, as I would say, discriminating equipment.
Right.
I mean, it has advanced quite a bit. In every year, there's always new equipment coming out.
Well, and I also say that we have excellent equipment. Not all laboratories have the newer equipment, and we're using an LC-MS-MS. So that A lot of labs are still using GCMSs. They work, they're accurate, they're getting good results, but an LCMS is an excellent piece of instrumentation.
And I think this is another example of a time you may need to get your own expert if you're a defense attorney, or frankly, if you're a prosecutor and you're wondering, there's this poppy seed bagel thing fly, right? Asking the lab is a good starting point. If you're still not certain, asking an outside expert. If you're a defense attorney, AKE versus Oklahoma is the United States Supreme Court case that says you get an expert. And if you're with the public defender's office and you need funding, I know there's people out there rolling their eyes because you're not getting funding. But you should be asking for experts if you believe that you have a concern, particularly in a case where you've done some. I mean, the web's a wonderful thing and a dangerous thing. It at least could provide you some support for a request for an actual expert in this area.
Right, and that's why you don't go to, say, the general, like Google poppy seed bagel. Okay, you might get a good place to go to get one, but that's not going to give you the scientific evidence that you need. That's, again, if you go to the Clearinghouse website, which is free to use, you can get information there. And we're building on this every single day with our pro bono students as well as researchers. So that's one of the things you want to look at, because you can't convince the court unless you have some data that you can use. We have a few more questions. Actually, Anonymous 78801 got back to us. Okay. The question is the 2009 NAS report basically said there were many areas of forensic science that are not reliable. So does that report change the way, or perhaps has that changed the way that analysts should testify? Well,
analysts should testify.
Well, maybe that. I think maybe I would say, because people reacted the way they did, it was a big wake-up call, I would say, to the forensic science community. And yes, we would not have had the National Commission on Forensic Sciences founded, and have the funding to do that, nor have the NIST Organization of Scientific Area Committees, which has over 540 scientists and lawyers working together. And we'll talk later about how lawyers can get involved in this whole area. It's very important that we don't wait and have things happen, that we can be part of the process as well. And some scientists may say we don't want the lawyers in there, but of course, what are we doing? We have to go ahead and go to court with these pieces of evidence. And so that's a very important thing to weigh in on this at the time. So I don't know if that helps us. I mean, there's been training that's come out of that, perhaps.
Yeah, I would say that it was a wake-up call, and laboratories, accrediting bodies, the OSACs that have now been formed. A lot of things have come out of it. And so I would say it's not necessarily the way they testify, but it has to do with the way analysts are trained. We're very careful about validating the methods that are used, very careful about the technical procedures that are used, the availability of those procedures, the quality assurance. So for that which was said in the NAS report about some of the areas of forensic science, I don't think it's all of the areas of forensic science, and I think that there's been very stringent practices in laboratories for some time, but they've improved quite a bit.
Mm-hmm. And I think you have to remember that the NAS report came out in 2009, right? It's a stagnant document, and what we saw was sort of forensic discipline specific. So the fingerprint community, for example, really stepped up and said, you know what, you're right. We haven't really done any studies on is 8 points enough, is 12 points enough, is 15 points enough. And there were a couple of studies that were published from different groups in latent prints talking about what is enough, what is significant. The question documents section really also started doing some studies about what about cursive, what about printing? Can we really make these distinguishing declarations that we've been making? Other disciplines have not perhaps been quite as diligent, and I would note that, as Carol said, the Clearinghouse maintains a wealth of knowledge on different studies that have been published and different papers that have been presented, specifically addressing some of the things that were brought up in the NAS report.
Yes, and I think this is, and there, if you watch the news at all, you've seen in bite marks, there's a lot of controversy right now. Hair, trace evidence, I would say hair and fiber evidence, if you saw what's going on, which was, of course, a joint study done by both the Innocence Project and the FBI, where they went, and recently at the American Academy of Forensic Sciences meeting that was in Las Vegas, that was in February, the Deputy Attorney General came and said that changes will be made. And I think that's a very good document as to to have her speech, to use that to show, okay, here's the changes that we're going to undertake, and let's see what's going on. Now, one of the questions here from Philadelphia 12 said, do you have any recommendations for experts in each of these disciplines? Well, I can tell you that you can, of course, you can search people's names in actually the ncstl.org database, but the other thing is to go to different professional associations, like the American Academy of Forensic Sciences. You can go ahead and search through the directory. The same thing with AFTE, for the Association of Firearms and Toolmark Examiners, every single professional association. And I can tell you that I actually, with LEIC, that's also the group that helped us with this particular broadcast, we did a continuing education course just on how do you basically find experts and how do you vet experts, both an opposing expert, how to go ahead and challenge that person as well. And you can find that also on our homepage of the clearinghouse. Now we have another question here. It says, in terms of changing how scientists testify, it is critical for lawyers to use the report to limit the scope of testimony and to ensure clarity. This is more of a declaration, I think, here. I don't know if you want to weigh in on this comment at all, Christine?
Well, I think one of the things that this comment highlights is we as lawyers use words in a certain way and we think they mean certain things. Scientists also use words in certain ways that don't necessarily mean the same thing. And so it's important to sit down with the scientist ahead of time, regardless of whether you're prosecution or defense, and say, when you say identification, do you mean to the exclusion of all other people or bullets or fibers on the planet? Well, typically the answer is going to be no, right? But those words maybe aren't in the report. Maybe you want a motion in limine to a judge to say, I want the whole thing in here and here's why. You may need to take some testimony to educate the court on why this is a relevant pursuit of yours and not some wild goose chase. Firearms is another one. I know we're going to be talking about that in just a minute. What would a report say in a firearms case, and what is their standard for what is or isn't a match or an inclusion? And so it really is critical for the lawyers to understand that every word in science has a meaning. Frequently, you will get a glossary if you ask for it from your crime lab, so that you know what this crime lab's meaning is for this word. Understanding, of course, that unfortunately and frustratingly, the same word may mean different things in different parts of the same laboratory, depending on what forensic discipline you're working with. So each time, in each case, you're going to need to call the relevant analyst and say, do you have a glossary for me? And then if you still don't understand, and you may not, you need to sit down with that scientist and say, I need you to explain this to me.
And actually, this is one thing that the National Commission on Forensic Science is looking at. One of their subcommittees is looking at terminology and say, can we have some consistency with what these terms mean? You can also find all of that. The NCFS has their own website, and it has all of the Commission's work product, which are different reports, directives, et cetera. And I think that's another place that you really need to familiarize yourself with. Okay, why don't we do this? Why don't we move on to drug identification? That'll be our next discipline that we visit.
Hi, I'm Emily, and we're here in the drug identification section, and I'm going to be showing you how we would walk through and work a drug identification case. What we do here is we test for drugs that are found outside of the body prior to ingestion. We see things like powders, capsules, tablets, plant materials, liquids, and we test these to determine if there are any controlled substances present in those samples. This is a piece of evidence that I have picked up from our evidence receiving unit via a secured transaction. So I'm just going to walk you through the process of how we would work a drug case such as this one. First thing that I'm going to do is to check to make sure that all the information on the piece of evidence matches the submission forms that we receive from the officers. The next thing that I will do is check to ensure that all the seals are intact, that the evidence itself is sealed. After I have confirmed that all that information is correct and the evidence is sealed, I will then open the evidence and begin my analysis. In drug identification, one of the biggest things that we're looking at is weights of our samples. So the very first thing that I'm going to do is weigh the sample. After I've weighed the sample, I'll take a small amount for a preliminary test. This will help me to determine what type of drug it is I may be seeing and help me to know which direction to go with my analysis. After I've performed a preliminary examination, I will then perform a confirmatory test, which is very specific to a chemical compound that we would see in drug testing. We have various pieces of instrumentation that we can perform confirmatory tests on. Much like the other sections, we are comparing knowns to unknowns, so we have an unknown evidence sample that we're comparing to known drug reference standards. Once all that analysis has been completed, I will prepare a report with my findings and all of my data. Another scientist in our section will then review the data and my findings to determine if they would come to the same conclusion. This is what's known as a peer review or case review process. After that's been completed, we will issue a final report to our customers, and at that time I can then take the evidence back to our evidence receiving unit so it can be picked up by the submitting agency. So after I've completed all my testing for this piece of evidence, which was a white solid material, I've compiled all of my results and findings and my weights into our computer system. I have generated a report, which you can see says draft. So this means that it has not been sent yet for technical and administrative review. Once that is completed, it will then be administered to our customer who has requested the evidence be tested. So I'm just going to go over a little bit what's in our report. Again, this is a draft copy, so it's not the actual final report. We basically, like every other unit, we have all of the identifying information with the submitting officer, the subject, and a description of the evidence, which in this case was a white solid material. The net weight of this total sample tested, a net weight basically is just the evidence without any packaging material. In this case was 98.52 grams plus or minus 0.06 gram. Now the plus or minus 0.06 gram is what we refer to as our measurement of uncertainty. After all the preliminary and confirmatory testing was completed, this case was tested positive for cocaine in the sample tested. And that will be listed right here. As I mentioned, we're 99.73%, using a 99.73% confidence interval. That just has to do with our weight that we reported. And once this report has been technically and administratively reviewed, then my signature would appear on the report and it would be dispersed to the customer.
I'm now going to turn this over to Anne to talk a little bit more about reports and also this measurement of uncertainty.
So if you get a drug identification report, it's fairly simple. It's going to identify, it's going to put the weight and the uncertainty of measurement for that weight, and then the results. In this particular case, the white powder that was found in the vehicle was cocaine. And we have measured that with a 99.73 confidence level. In toxicology, we also mentioned measurement uncertainty. So this is a concept where a laboratory will have an uncertainty budget. In other words, they'll put sample after sample after sample, different pipettes, different people, different balances, and so that the concept is that at the time a sample is weighed or measured or tested in our laboratory conditions, the weight recorded is in fact the weight of the sample, and we can say this with confidence. And the confidence interval is what the budget determines. And what in our laboratory we're reporting at a 99.73 confidence interval, which is K3. So that we know that any person or any different person on any day is going to be within that confidence interval.
When you get new staff, do you have to recalibrate that then?
Yes, when we get new staff, they go through training for weighing or pipetting or whatever it is. Their weighing and pipetting is added to the budget that we have to determine our confidence interval, and that's added to our reports.
Okay. Christine, you want to talk about some discovery matters or about this?
Yeah, I do not wish to go any further on the confidence interval right now. I think that's an important topic which I believe we're doing in another
Yes, in another
presentation
segment.
later.
Okay.
Two observations for discovery purposes. In this particular laboratory, the analyst told us that her weight of the sample was without packaging. That's not true in every laboratory, so you need to find out from your laboratory when they're saying what the weight is, whether or not they're including, you know, all of the packaging, which might include the duffel bag within which was the cellophane wrapped drugs, or is it just the cellophane and the drugs, or alleged drugs, or is it just that white powder? The other piece that I think is really important in this particular case they talked about, and this is common in drugs outside of the body in doing testing, she talked about a preliminary test and a confirmatory test. And there are important differences between the two, both for our chemical testing and also in DNA analysis. So preliminary testing, and maybe you see your law enforcement officers doing this on the street with some sort of field test that they do to see, you know, they'll put a little bit of the substance in a test tube, knock it around with some chemicals, and maybe if it turns orange, it could be meth. If it turns green, you know, maybe it's, I don't know what turns green. I think blue, cocaine is blue. But these are preliminary screening tests. They're not a final test, and they cannot be used. And if you look at the preliminary test kits, they'll specifically tell you that that can't be used as proof beyond a reasonable doubt in a criminal case. You need that confirmatory test that tests specifically for methamphetamine. We go back to the poppy seed example. With over-the-counter drugs such as Mucinex, you can get a false positive, or frankly, it would just be a positive test result on a preliminary test, where if you did that confirmatory test, you would find out it is not an illegal substance.
Now, we have a couple of questions that came in, and one question asked, with the case or peer review process, does that mean it's retested and two different analysts give opinions? What does it actually mean, I guess?
It's a very common, it's a requirement of our accreditation that any test, an analyst does a test all the way through, and they come to a conclusion. Another qualified analyst will then go through and make sure that all the I's are dotted and all the T's are crossed, and that indeed this is a confirmation of the test result.
But they don't actually redo the
They
test.
do not redo the test.
Unless it's latents, right? Because then that is the test.
In latents and firearms, in our laboratory, we verify an ident. So the other person will go all the way through and look at it. But in drug identification, the data is so apparent that another examiner can go through and look at all the data and say, yes, it is, indeed.
Is that because there's maybe more subjectivity, could you say, in those other areas? Is why they asked them to do an additional test or do the same test over?
Well, I think you were looking at patterns
Right,
in
pattern
latent prints in firearms. So here we're looking at a spectrum, spectrum. So it's a lot easier to identify that, yes, it is. It is the substance that was identified, yeah.
Now we have, here's a question. If I receive a final report with draft still showing on the front of the report, should I assume that the technical administrative review has not been done? I regularly receive final reports with drafts still showing on the report. Christine?
In my experience, what would happen is I would get that original report from the laboratory saying, it is fill in the blank. When you ask for the complete file, you're going to get a copy of the file, which includes a report that says draft on it, because at one point that final report was not in final report form. It was in draft form, right? So they keep a copy of that in the file. You'll see that stamped draft on it. You may see the handwritten initials of somebody who's crossed off a misspelled word or added an apostrophe or changed a semicolon to a colon, which would happen maybe in an administrative review. And then when you look at your final report that you got originally, it's a complete form. And I may be mistaken, but I don't think labs are allowed under ISO 17025 to send out draft reports.
No, our report is final. When it's final, it does not have draft on it. The milestone after the administrative review sends the report.
Okay. Well, I'd like to, maybe we should ask the person who sent this question. This is you, Anonymous 65761. Are you a prosecutor or a defense lawyer? Did you get this in discovery or something? I don't know if that matters.
I don't think it would matter.
No, but why are they?
Even if it's a prosecution lab, the lab shouldn't be giving
out draft reports. Right, because then I was thinking if you were a prosecutor, then hand that over in discovery, again, you've got this draft situation as opposed to a final.
Yeah, draft to me means draft.
This may merit a phone call to your crime lab and the author of that draft to find out what's
But
going
you
on.
say that you receive them regularly, so I don't know, we may talk later. So that's something to consider. Well, shall we move on to firearms and
Let's move on.
okay, let's move to
We'll let
firearms.
Anonymous
Stan?
see what they can find.
My name is Bridget Chambers, and I'm a forensic firearms examiner. And today I'm going to briefly go through some of the examinations we perform in the firearms unit. Initially, I'll receive evidence from the evidence receiving unit. At the window, I will check for seals. You'll see it's all marked with the barcode. After I receive my evidence, I'll open each item of evidence and examine each item individually. I've got a cartridge case, a bullet, some bullets and bullet fragments, and a couple firearms here. I'll write up a set of notes in the computer, going through, examining each piece of evidence, writing up the class characteristics I see in all the ammunition components, along with individual characteristics. So initially, for a cartridge case, for example, this cartridge case you can see on the screen, this right here is a stereo microscope. It's a 3D magnifying glass, if you will. It allows me to look at the cartridge case up close and examine the class characteristics of the item. Class characteristics are set by the firearms manufacturer. So for a cartridge case, it'd be the breech face marks or the firing pin impression. And when I say breech face marks right here, you can kind of see the parallel lines here, and then along with the hemispherical firing pin impression. I document all this in my notes. Then I move on to the next item of evidence and do the same type of process. So in this process, the stereo microscope is one of the primary instruments I use. This is a pair of calipers. This allows me to measure the lands and grooves, the measurements for the bullets. The lands and grooves are rifling in the firearm. Again, that's set by the manufacturer. Number of lands and grooves, direction of twist that provides a spin on the bullet as it's traveling out of the barrel. These class characteristics allow me to either eliminate or narrow down the pool of possible firearms that could have possibly fired that cartridge case or that bullet. So in this instance right here, I have a bullet. The class characteristics of this bullet is 6 left. Class characteristics of this bullet fragment is 7 left. So these two firearms I have right here, one of them is 6 left, and one of them is 7 left. So I can automatically narrow down one firearm for each bullet. The next in my progress, I will examine each firearm, again document it in my notes, document all the class characteristics of each firearm, and then I'll perform an initial examination on the firearm, examining the firearm, manipulating it, making sure it functions as it's designed to. I'll perform the function exam initially at my desk, document everything about the firearm, make, model, serial number, class characteristics of the firearm. Then I'll perform what's called a trigger pull, which is the amount of force that's required to pull the trigger. Then I'll move into the range and test fire the firearm. This is the ammunition reference collection. We use this in our casework to try to replicate the similar type of ammunition that's used in the case. For instance, if the ammunition is brass case with a nickel primer, we try to find similar brass case nickel primer, if not the same manufacturer, very similar. So in my case, I had a nickel case and a nickel primer. I don't know if I have anything like that in my reference collection, but I will definitely try to find something similar or get a variety. The reason for that is the metal has a chance to mark a little differently for different types of metal. So if it's a brass primer or a nickel primer, it can mark a little bit differently. I like to do different types of metal, so when I do my comparisons of my test-to-test, I can see the reproducibility of the firearm and how it marks on the ammunition. So in this case, I chose this type of ammunition that has a brass case and a nickel primer. Since my evidence has a nickel primer, I at least would like to keep that the same. This is the water tank. In order for us to obtain pristine bullets, we shoot cartridges into the bullets into the water tank. For safety reasons, we're not 100% sure of the functioning of the firearm. We do perform primary safety function testing on the firearm without ammunition in it to determine if it does fire fully automatic, but just for extra safety precaution, we only load 2 into the magazine. That way, if it does go full automatic, only 2 will be expelled. Firearm is clear. Now that I've performed my test fires, I'll retrieve the bullets out of the water tank. Now that I've done my test fires, I retrieve the bullets out of the water tank and they are in a pristine condition. This is our firing range. We can perform additional testing on the firearm downrange if we need to load up the magazine fully and fire the firearm with a full magazine. This is where we would do that. We also perform distance determinations, which is another examination we provide for the laboratory, and this is where it would be conducted. Now that I've created my test fires, I can compare my unknown, which is the evidence, to my known, which is the test fire, to determine if the evidence cartridge case was fired in the firearm. Initially, I take 2 test-fired cartridge cases and place them on the comparison microscope, which is 2 microscopes connected by an optical bridge and 1 set of eyepieces, which allows me to look at 2 things at the same time. So first, I will compare my 2 test fires to determine what class and individual characteristics exist. As I stated earlier, the class characteristics are set by the manufacturer, which is in this instance, the parallel lines and the hemispherical firing pin impression. Once I've determined that there are similar class characteristics, I go further to look into the individual characteristics, which individual characteristics are left incidental to manufacture or during the abuse of the firearm itself, which allows me to determine whether a bullet or cartridge case could have been fired in a particular firearm. These are my 2 test fires. The line you're seeing on the screen is my hairline. It allows me to move back and forth to look at all the class and individual characteristics that exist in these test fires. So first I'm going to use the gross striations to line up the 2 test fires, and then I look in between those striations to look for all the individual characteristics and determine the reproducibility of this firearm. Once I've completed that, I'll remove one of the test fires and then place my evidence next to the test fires. Again, I'll use the gross marks to determine the general area of where they line up, and then I'll look in between the gross marks at all the individual characteristics between these lines, along with, in the firing pin impression, all the gross marks and individual marks that exist there. And in this instance, I would identify that the cartridge case from my evidence was indeed fired out of the firearm that was submitted. At this stage in my examination, I will bring test fires test-fired cartridge cases into the NIBIN system, which this is the National Integrated Ballistics Information Network. Specifically, the instrument is called brass tracks. We take test-fired cartridge cases or evidence cartridge cases found at scenes, enter them into NIBIN, and NIBIN has an algorithm where they bring up best possible matches to my evidence or test fires. In this instance here, and this is where I've acquired the different images for the test fire cartridge case here. And then over here is my list of possible correlations to that test fire. I'll click on one of the possible matches and look at it side by side, generally like on the comparison microscope, except all I have is images. I'll look at the test fired cartridge case next to the possible match, manipulating essentially like I would on a comparison microscope, looking at the class and individual characteristics. And if I've determined that 2 cartridge cases are possibly a hit, from there I will request the evidence from the agency to be resubmitted to the laboratory. I'll take the test fire and the evidence cartridge case and compare it on the comparison microscope as I had shown earlier. NIBIN is just an investigative tool. We would never make any identifications based on the screen. Once I've completed with all my examinations and all my comparisons, and my work has been verified by another qualified examiner, I will then package up all my evidence and return it back to ERU. I've placed my markings here on the package with my case number, item number, and my initials, along with on the seal, I've placed my initials. And then I will take it back to the evidence receiving unit to return it.
We've received a few questions during that video which we'd like to address. In fact, we had 2 asking, why is the examiner not wearing gloves when she handles the evidence? Ann?
Well, in our laboratory, before the evidence gets to the firearms laboratory, it's been triaged. So it would have been processed for latent prints or DNA collected and then repackaged and sent to the laboratory for the next analysis. So we're not concerned at that time about DNA or latent prints on it by the time it gets to the firearms laboratory. It's triaged.
Are there any safety concerns also?
One of the other concerns is that when we're test firing guns, gloves can sometimes get in the way or get caught. And so there is a concern. We have a concern. I think some laboratories do fire with gloves on, some do not. We are not at this point because we've already processed the gun.
Okay, and you have some discovery helpful hints with this area?
So I thought it was a really good question, and yay to the lawyers who said, yeah, why isn't she wearing gloves? Again, if you're getting your discovery and you've got your chain of custody, you're going to be able to see whether or not it was swabbed for DNA before or after the firearm was fired. You may also discover in your chain of custody that perhaps a law enforcement officer brought the weapon to the laboratory while it was still loaded. Most laboratories won't accept a loaded gun. Somebody's got to unload it. So you need to ask yourself, who unloaded it, when did they unload it, how did they unload it? Maybe the next morning it actually came into the lab still loaded because somebody didn't notice. Then they notice it and it goes up to the firearms unit to unload it. Did they wear gloves then? Those are all legitimate and important questions. When it comes to crime lab employees, it is common for the lab to maintain a database of employee DNA profiles. So if someone in the laboratory unloaded a gun, you would see that in the chain of custody, and if then it was swabbed for DNA and it got a hit against this employee, we would have an explanation for it. Most law enforcement agencies do not give up their DNA profiles to the crime lab. So if a member of law enforcement was the one to have unloaded that gun, or frankly even collected the gun at the crime scene without gloves, you would get an unidentified profile.
Okay. Now we have a few more questions here about what is the educational background of your analysts in the laboratory?
Well, first I'll say that accredited laboratories, at least ASCLD lab accredited laboratories, there's a requirement of a Bachelor of Science in Natural Science for the toxicology, drug identification, and forensic biology units. Latent prints and firearms do not have that mandatory requirement, but I think that you'll find it common for them to have that requirement. We do have it for anyone we're hiring new. We have a few people who've been there in excess of 20, 25 years in latent prints who don't have that science degree, but we won't be hiring anyone new that doesn't. So I think it's definitely going that almost any forensic scientist is going to have that degree.
Okay. And Christine, you want to talk about competency, I guess, versus educational background?
Yes. So a couple of things. First of all, I think it's completely legitimate to request the analyst's resume when you're making your discovery request so that you can find out what it is that their educational background is. But the other piece that I don't think lawyers have enough information on is what do the labs do when they hire a new analyst? You know, they don't just put them on the line. There are a series of steps that are required. So in the beginning, when a new analyst is hired, even if they have prior experience, there's a training program that they have to go through. And there's hands-on training, there's reading materials that need to be consumed. Some laboratories will do actual tests on specific reading materials. There's a mock trial that an analyst is subjected to. There are sometimes oral boards that an analyst has to go through. And this, in an accredited laboratory, this process will be written down, both what is the process for, say, firearms and tool marks, or what is the process for latent print examiners, and then also what documentation do we have that this particular analyst completed satisfactorily all of these things. So first, an analyst has to be competency tested after their training period. And once they pass their competency test, they're put on the casework, and then we move on to proficiency testing, which we've touched on before.
Right. And another thing that we want to talk about is, I think, is about the difference between accreditation of a laboratory and, again, certification of an individual examiner. So that's so that you know the difference. One is individual, that's certification of the examiner, but accreditation is of the laboratory as a whole. Now, we have another question here. Isn't it true that the standard for whether there is a ballistics match, and I think we really mean a firearms, because ballistics is different than firearms, actually, but whether there are sufficient corresponding points, and thus isn't that, I guess, unscientific?
Well, I guess I want to say it's similar in some ways to latent prints, but we're not looking at bifurcations or something. We're looking at the striations. But a number of the things that Bridget talked about in her presentation, we're looking at a lot of different things: class characteristics, gross characteristics, and then the individual characteristics. So side by side on a comparison scope, we're matching those up. And this is not a quick comparison. It takes a lot of experience and a lot of time. So again, we're looking now at comparison science. And that, well, if one considers that not science, it is, you know, I think that's something that the NIS report brought up, and we're trying to go deeper and deeper into, so that there are more things that we can say that support the testing.
And there has been, I'd say, a lot of, I don't know, I want to say criticism, but there's been a lot of second looks at pattern recognition.
Correct.
Any type.
Yes.
I mean, whether you were talking about fingerprints, striation marks, et cetera. Now, here's another question here. It says, aren't there instances where the NIBIN system returns better matches or hits to uploads than the known standards? The computer algorithm suggests there are better known matches than the known match itself. How does science, this is in quotes, reconcile this? I don't know if we have to leave this for a firearms examiner,
which is
right?
Not me.
Right.
Yeah.
And a FRI hearing, probably. I mean, it's a good question in that, you know, it's subjective. Is it? Well, yeah, because there's not a mathematical formula, and different analysts are going to feel different levels of comfort. It's not uncommon for two analysts to look at the same piece of evidence and one person to be comfortable with saying that this is an exclusion or an inclusion, whereas somebody else might say, you know what, I'm just kind of in the middle. I'm not really certain that I can make that determination. So in any given case, that is an obligation of an attorney, right, is to vigorously examine the strength of the evidence and really sit down with the analyst and say, well, what'd you see that made you think this how'd you come to this conclusion? Maybe hire your own expert if you're the defense. What does your defense expert say? Because there is a level of subjectivity to it, and I think that most scientists would acknowledge that. Does that mean it's not science? Well,
Right, and I think, well, that's again where you have to have maybe your own expert or find out what is, again, when we have standards, that might help also.
Yes.
And this development of standards is very important to the whole forensic community. We have one more question, then we're going to move on to DNA. It says, what's the proper procedure for dealing with evidence that arrives at the laboratory unsealed or without a chain of custody? In other words, I guess from the scene and it gets to the lab, but it's not well documented by the time it gets to you, Anne, at the laboratory.
Well, that would be quite unusual, because if someone just brings something to the lab to be tested, it needs to be sealed properly, and there needs to be a chain of custody on it. So we won't receive it unless it is done properly.
So you would refuse it then?
Yeah, we would. We would find a way to, well, whoever was bringing it there would say, this needs to be packaged properly. It needs to have a chain of custody. So that they can't just bring something to the laboratory and it be tested in our situation.
Mm-hmm. Okay. Stan, why don't we move on to our DNA clip?
Hello, my name is Benjamin DeBlanc, and welcome to the Forensic Biology Unit. When a request is submitted for DNA testing, a forensic scientist from the Forensic Biology Unit takes possession of the evidence from the evidence receiving unit. The evidence is then processed in the Forensic Biology Unit. Once in the lab, the scientists will take precautions to protect themselves and the condition and integrity of the evidence. As you can see now, the analyst is taking the precautions necessary to protect the integrity of the evidence. This includes wearing the appropriate personal protective equipment, such as lab coat, face mask, and gloves. The analyst will also clean the workstation with 10% bleach solution. Now the analyst will then remove the evidence from her personal storage locker, where the evidence is kept when the items are not being tested. Before testing begins, the scientist will document the condition of both the evidence and its outer packaging. This can include a physical description of the item and/or photographs. The scientist is now ready to begin screening for biological materials, which will include blood, semen, and saliva. Biological materials are a good source of DNA. In this case, the forensic scientist is examining a t-shirt from the suspect for blood. A blood stain is reddish-brown in color and is usually visible to the naked eye. If a visual examination is not adequate for the type of evidence being examined, an alternate light source can be used to identify possible biological stains. For example, blood or semen. Once stains are detected, chemical and/or serological tests are conducted to determine if those stains are biological in nature and if it is of human origin. The scientist swabs the reddish-brown stain on the subject's t-shirt and uses a small cutting of the swab for the chemical screening test for blood. A pink color change indicates a positive result. Next, the remainder of the swab is used for serological screening test to determine if it is human origin. The appearance of two pink lines in the test region of the card indicate a positive result. Therefore, testing on the stain found on the subject's shirt indicates blood of a human origin. During the course of testing, each item is cleaned thoroughly during the process. Bottles, cans, and cigarettes are a good source of saliva, which contain DNA. Areas that come in contact with the mouth are swabbed for DNA analysis. The scientist uses a wet-dry technique to collect possible saliva around the opening of the can. These swabs will be cut and taken forward to DNA analysis. Swabs of possible biological material collected from the crime scene or from an individual are tested in the same manner, as is the swabs here taken from the trunk of the subject's car. The swabs taken from the trunk of the subject's car also tested positive for blood of human origin. Thus, samples from both the subject's shirt and car will be taken forward to DNA analysis. These samples are known as question samples because the contributor of the biological material is unknown. Once all samples have been screened for biological materials, the DNA process begins. The scientist swabs a reddish-brown stain on the subject's t-shirt and uses a small cutting from the swab for a chemical screening test for blood. A pink color change indicates a positive result. The first step to this process is to extract DNA from the substrate and other cellular materials. Since DNA is found within the cell, the scientist adds a lysis buffer to the samples. This will break open the cells and expose the DNA. Then, the samples are placed on an instrument that separates and purifies the DNA. Once the DNA is extracted, it is necessary to know how much DNA was obtained for each sample. This process is known as quantitation. Using too little or too much DNA in the next step of the DNA process will greatly affect the quality of the data obtained for analysis. The third step in the process is called amplification, or PCR, which stands for polymerase chain reaction. PCR is like a chemical copy machine. With this technology, the analyst can take just a few copies of DNA from the cells obtained from the piece of evidence and generate millions of copies of DNA. Once the copies of the DNA are generated, the sample is now ready to proceed to the next step, DNA analysis. In the DNA analysis step, the lab utilizes capillary electrophoresis in the form of a genetic analyzer, coupled with computer software, in order to detect the DNA types present in a sample. The DNA molecule contains a very large amount of information. However, forensic DNA focuses on a very small section of DNA. In this particular lab, the analyst analyzes 24 different locations on the DNA. The data is then ready for interpretation. When the DNA types of all 24 locations are considered together, the results produce a profile that differs from person to person. Only identical twins will exhibit the same type at all 24 locations. The most useful information to the customer, i.e. law enforcement, court system, etc., is generated in the final steps. Once the DNA profiles are generated, those from the evidence and those generated from the samples of individuals, samples are compared to determine a match. Does the DNA profile generated from the evidence match the victim, the suspect, or some unknown individual? If profiles generated from an unknown individual, these profiles may be searched through the DNA database that houses DNA profiles from other evidence from other crimes and from arrestees, suspects, and convicted offenders. Once the interpretation is complete, a report will be generated, firstly including the serology results or the presumptive screening results, including first semen and blood, also including the DNA results and any of the comparisons made off the generated profiles. A small portion of DNA cases will finally make it to the courtroom, where the analyst will explain the testing and results to the court. Once the writing of the report is complete, it goes through a technical and administrative review, to where another analyst will have to concur with the results presented in the report. Once this is complete, the information will be released to the customer, i.e. law enforcement and the court system.
Well, first we're going to have Ann talk a little bit about the language they use in the lab report with the DNA analysis.
We're running a little short on time, so I'm going to be as brief as possible here. The language we use in our laboratory is meant so that it's easier to understand when you're reading our report. So this is an example. Blood was identified on the swab from the car. A single interpretable DNA profile was obtained from the swab. This DNA profile matches matches the DNA profile obtained from the buccal swab collected from subject B. For 22 loci, The frequency of occurrence of the DNA profile obtained from the swab from the car for unrelated individuals is approximately 1 out of X times 10 to the 29. The current world population is approximately 7.3 times 10 to the 9. The DNA profile obtained from the buccal swab from subject A is excluded as the source of the profile. So for each sample, we're going to go through something that sounds like that, saying whether they're included, excluded, and approximately that number in as simple a language as we can, because that is one of the challenges in a DNA report. When we have mixed profiles, it'll go through the same thing, and it'll give the numbers and try to describe the mixed profile. If it gets more than 2, then we're looking at some deconvolution, and that's even a further discussion.
A challenge, yes. Hey,
Do you have a seminar?
Right, that's
Right.
true. And I think if you have a few take-home messages with general discovery.
So in addition to all of the stuff that you want that's in the file for general discovery, if the lab that you're working with is accredited, I want you to know that there are documents that you should be reviewing. There's a preliminary report. Every 5 years, the lab has to be audited by an outside agency or outside auditors that will come in and review the policies and the procedures and the steps and the standards, and they'll write up a preliminary report saying, you know, you don't have anyone who knows CPR, you're using expired reagents, whatever the criticisms are. They give the lab 3 months, and they come back 3 months later and they issue a final report where the accreditation is maintained or the accreditation is revoked. You should be looking at both of those documents. You should also be asking for internal audits, which need to be done by a crime laboratory in order to maintain their accreditation. And those are done on a schedule. And I used to ask for the last 3 audits when I was a defense attorney. I worked in a state where discovery was very open. I don't know that you're going to get that from every state, but it's certainly something that you should be considering, because that's where you'll find highlights on whether there are problems, systemic problems, or occasional problems within a laboratory. I think we're up against the clock. So
Yes,
I'm
we
going to
are.
Stop talking.
Okay, thank you, Christine and Ann. I want to thank all of you for watching today's webinar. We'd like to provide you with information regarding new and upcoming training activities that we have. We have opened applications to our 2-day live crime scene to courtroom training for capital litigants. This training is going to take place on July 11th and 12th, that's 2016, on St. Pete Beach, Florida. The training is provided through the Bureau of Justice Assistance. The grant provides for participants transportation, lodging, and per diem. The training is for equal numbers of prosecutors and defense. This will be for the East Coast. We're going to have a West Coast training that's identical, which will take place in 2017. The application for this training will be emailed to you following this seminar. Apply soon because we are limited to 76 participants. You'll be notified of your acceptance a month in advance by June 10th. Our third webinar, which is going to be Forensic Pathology Essentials, will be aired live on October 13th from 12 to 2 Eastern Time. We'll email you that registration information as well when it becomes available. Once again, please remember to fill out the online survey so you get your CLE credit, and we look forward to seeing you either in July or at the online thing in October, and we hope maybe to see you at both. And on behalf of Stetson University College of Law, the National Clearinghouse, the Bureau of Justice Assistance, my guest speakers, and also myself, thank you for tuning in.